I suppose most of you have seen a crystal at one time or another, probably in a natural history museum or in a chemical bottle. Here's an unusually big crystal, dug out of a clay pit in Brazil. Here's a smaller one, broken from the side of a cleft in the rock in Arkansas. But crystals aren't always big, beautiful things like this. As a matter of fact, crystals are everywhere. The salt you use to flavor your food, for example, it consists of little crystals of sodium chloride. You can see their shapes by looking at them through a magnifying glass. Little cubical crystals of sodium chloride. Snow. Here are some enlarged pictures of single snowflakes. Each is a single crystal of water. Here's a crystal I like especially well, probably because I made it myself. It's a crystal of alum. As a matter of fact, you can make a crystal just like it. I put some directions in the film notes in case you want to do it yourself. You buy the alum you need at a drugstore and grow the crystal in a mason jar. If you do this, I'm sure you'll be very much impressed by one thing. The crystal keeps growing, maybe for a week. It keeps getting bigger, but all the time, it has plain faces, meeting in sharp edges. You can see I haven't ground the faces on this crystal or polished them at all. This is just the way the beast grows. It almost seems as if you were getting something out of nothing, something with a shape all its own, which it decides all by itself throughout its career. In order to grow a single perfect crystal as big as this, you have to take pains and let everything happen slowly. But you can see what's actually happening by letting things happen a little bit faster and looking at the business under the microscope. I'm going to take a solution of alum, which is just itching to deposit crystals, and make a little pool of it on the microscope slide, and then add a few little crystals of alum to give the alum something to deposit on. And then get myself in focus and let her rip. There they are. You can actually see them grow if I turn now to a higher magnification. The little crystals keep pretty much the same shape as they grow, just getting bigger. Naturally, they all sit down on the microscope slide on one of their biggest faces. So you see the shape of the crystal depends mostly on what the crystal is made of, and not on its size, so long as it's free to grow in all directions. Now, crystals don't only grow out of solutions. They grow out of gases. Snowflakes, water crystals grow that way. And one of the most important places where crystals grow is out of melted materials when you cool them. Here I've got another powder you can get at the drugstore called Salal, which melts to convenient temperature. I'll put a little of it on a microscope slide. Then I'll carry it over here to the hot plate and melt it. And now let's go over here to the microscopes. There's one growing, turning very slowly in the liquid as it grows because it hasn't quite sat down on the slide yet. It seems almost to push those flat faces ahead through the part that's still melted. Of course, you know that the whole crystal isn't moving and shoving its front along. The liquid next to the face is becoming solid and adding itself to the face. But it's doing this in such a way that the stuff added on also forms a flat face, so the crystal keeps its shape while it grows. Now, I'll melt this